Hello everyone, this is Apolinario J. Balyanas Jr., an MIS student from UP Open University. Today I will going to discuss finite automata. The topic that I choose from my course CMSC201, Discrete Structure for Computer Science. Finite automata or finite state machines. It is a simple machine used to recognize patterns with an input from some character set or alphabet. The job of the finite automaton is to accept or reject an input depending on the pattern defined by the finite automaton. A finite automaton is an abstract model of digital computer. A common example of it is a switch, wherein it has a on and off states, and the initial state is in the off state. When you push the switch, it will move or it will create an action or movements from off to on. And when you push again the switch, it will create an action or movement from on state to off state. Finite automaton has a finite set of states, and its control moves from state to state in response to external inputs. Deterministic finite automata, or DFA, is a simple type of finite automaton. It consists of finite set of states, a finite set of input symbols, a transition function, a start state, and a set of final or accepting states. DFA is a 5-tuple notation. It is composed of set of states, input alphabet, transition function, initial state, set of accepting or final states. To give you a better picture of DFA or deterministic finite automata, we have what we call transition diagram or state diagram. It is a graphical representation of DFA. Just like, for example, a DFA that accepts all and only the string of zeros and ones that have the sequence of 0, 1 somewhere in the string. In the bottom left corner, you will see a diagram wherein circle represent a nodes or a states. Then you have your arcs and arrows represent transition function, and every arcs and arrows are leveled by the input alphabet. Then you have your start state, the initial state, arrow leveled with the start to the start state, and you have your final states indicated by double circles. So that is a example of transition diagram. Then another, you have your transition table. It is a tabular listing of a function. For example, again, a DFA that accepts all and only the strings of zeros and ones have the sequence of 0, 1 somewhere in the string. In the bottom right corner, you will see a transition table, wherein the rows of the table corresponds to the states and the columns correspond to inputs. The start state is marked with an arrow and the accepting states are marked with a star. For example, given a transition table, you need to draw a transition diagram for DFA. So this is the example of transition diagram, wherein it contains at least one and even number of zeros follow the last one. Example number 2, you need to create a transition table from a given transition diagram. So that's all. Thank you for listening.